Hello everyone and welcome to today's ISC Square Bangalore Chapter webcast, Security Analytics Making It Work. My name is Brito Siddhan of ISC Square Bangalore Chapter Board and I'll be moderating today's webcast. Today's featured speakers are Anubhav Wahie, Regional Leader, Cybersecurity Solutions Cisco, and Aditya Raghavan, Technical Solutions Architect Cisco. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the Zoho webinar interface anytime. Please note that this webcast is being recorded and a copy of the slides and the recording of webcast will be available for viewing later this week and can be found on Chapter YouTube channel. And with that, I would like to end the webcast over to Anubhav.
Just checking, are you able to hear me, Rito?
Yes.
Okay, great. So I'll just get started. Thank you so much for the introduction. As Brito mentioned, I have with me Aditya, who's one of our technical solutions architect, who will be jointly running this webinar with me. An extremely interesting topic, and I can promise you the next 90 minutes, we're going to keep you engaged because this is not just about a technology talk. It's about how technology can be made to use for you and how can it be made absolutely effective. Now, before I get started, may I request Brito to start with a quick poll because we wanted to get a perspective from all of you on what do you think about analytics. So Brito, could you put in the poll for us as we get started? So maybe we'll wait for about 30 more seconds and see what everybody has to say. And Aditya, you may want to read out the results for me. Do we have the results in? Right. So what I'm hearing is all of us have been able to see analytics work for us 100% of the time. Very good. Now let me kind of dip a little bit deeper. May I request Bina to put in the second question? Because that's the important one I'd like to know. Okay, we'll wait for another 30 seconds and super cool. So that's about 80% of you believe that analytics that you have leveraged in your personal lives has been fairly accurate, which means about 12% of you believe it's not. And that's where I want to start the conversation. Thank you so much for indulging on this very short poll, but this is going to be the basis of our conversation today. The agenda today is getting into details of what analytics is. We're going to talk briefly about what analytics really means and what is the importance of accuracy in analytics. We're going to bring out the domain problems in terms of understanding what's the difference between signatures and why do we really need to indulge in behavior-based analytics. We will then roll up into fundamentals that typically get involved when you run security and security analytics, and then get deep diving into artificial intelligence, machine learning, get into the dark data world. I think all of us now understand most of the traffic that we have in our networks is fairly encrypted. I think it's close to about 90 to 95%. And how do you really make sense out of that encrypted traffic? Go deeper into behavior analytics, and then try to conclude in terms of what are the outcomes we need to drive with analytics in security, what's the future, and we've kept the best for the last, which is showtime. We want to show you how some of this can be put to use. So without further ado, let me start with an example. I asked all of you a question: have you used analytics in your daily life? Well, I have used it, and clearly when I have used it while watching Netflix, I got Netflix to come back and tell me, because I watched World War II movies, I should have been looking at certain other movies which are similar to World War II. Well, I would stick to what 12% of you said. Well, it's helpful. It gives you a broad guideline, but if it's not done accurately, it may waver. Now, in this case, if you clearly see, this is about watching movies on Netflix. The stakes are low. But when you're talking about security analytics, it has to be far more accurate, because you may not have the opportunity to go wrong, because the amount of effort that goes in security and to make meaningful sense out of those analytics, if it wavers you and moves you away from accuracy, it could probably be detrimental. I'll take you another example which brings context into analytics. Now, all of us go to Amazon and buy a lot of stuff. I'm sure you must have been leveraging it all the more often now, given the COVID scenarios. Clearly, Amazon comes back and tells you, if you've bought a baseball bat, you would want to buy a ball. You may also want to buy a cap, anything and everything to do with baseball. And predominantly because people who bought this baseball bat actually bought these other items as well. However, if you were told that somebody who bought the baseball bat also bought a knife and also bought the pepper spray, clearly the context in which this analytics has to be conceived is going to be very different. Somebody buying a baseball bat with a knife and a pepper spray may not be to play baseball. It could be maybe on the baseball ground they're trying to do something else, but it's definitely not with the same intention that the baseball bat and the ball was trying to be bought. Now, the reason I'm trying to bring this up is, in today's time and age, when you are trying to classify observables, the easiest catch that we have is, let's look at threat actor activity, because that's easy to find. It's like going ahead and figuring out what your typical solutions from security perspective are telling you, and then try to differentiate it from your normal activity in the network. The problem is, we spend a lot of time in the noise that most of these security analytics will take you into, which is the weird stuff, the behavior which is not close to normal behavior, but it may not be necessarily threat activity, and a lot of time gets spent here. That's exactly why I started with the accuracy of analytics. If you're spending too much time on this weird stuff, and this weird stuff, to explain it to you in a different ways, I am seeing traffic coming in from multiple browsers on a particular endpoint. Well, at best, people use one or two browsers on their endpoint. If somebody is using 5 or 6, it may not be normal, but it's not necessarily threat related. So you get the point. The point is, I want to have analytical information, but I want to ensure that this analytical information is applicable to me from a security perspective and is slightly more precise. Because when it comes to stakes in security, the stakes are very high. And let me take an example to explain this to you. Let's take an example of a CFO. You had your analytics going, which indicated a suspicious activity on a CFO's endpoint. And clearly the decision made is, let's go ahead and quarantine the CFO's endpoint. Well, believe me, those who are in this business will realize going ahead and quarantining a CFO's endpoint means loss of time and resources. You better be accurate. You can't do it every day. You better be very sure that yes, there is a problem. And that's where I wanted to start with a strong prelude to the importance of accuracy, especially when it comes to security analytics. Now let's dive a little bit deeper into understanding the fundamentals here. How does it differentiate from other analytics? Clearly, in this case, we start with the end in mind. What outcomes will security analytics drive for most of these users that I'm sharing on the screen. What does it mean to an incident responder? What 5 questions is the incident responder in the organization searching for in his daily job or her daily job? And how is security analytics going to help you there? Likewise for the security analyst, likewise for the operations person, likewise for the threat hunter, and likewise for the CISO. Can I go back and ensure that I'm trying to answer 5 competent questions that these roles are trying to identify or get an answer for in their organization? Cut the noise. And this has to be built up from very strong telemetry, synthesized and analyzed to achieve these particular outcomes, which opens up the importance of understanding what ground truth means in supervised learning. Now, these are concepts that my colleague Aditya is going to further expand on, but my intent is to first get the base going in our conversation for the next 1 hour, because we're going to use this throughout the conversation. What do we mean by ground truth? Ground truth is the baseline basis which you will decide how the analytics are going to be accurate. Those set of questions, which we also call competency questions, to figure out what's reality. Let me take an example of ground truth. I'm sure all of you have gone ahead and used Google Photos, right? You click some photos and Google will come back and ask you, who is this? And you'll say, it's me. And I'll say, it's Anubhav. I'll tag myself. Now, going forward, now this is an example of supervised learning. It's basically throwing in questions to you and asking you who you are. You're answering the question, you're confirming it. The ground truth is correct. And based on this ground truth, any new pictures that it sees of me, even if it is probably at the airport, or if I'm probably on a holiday, it will say, you know what, I saw a picture getting uploaded. Is this you? And you confirm and said, yes, this is me, or it's not me. Now that question is a competency question. And if you go wrong on that question, your security analytics starts failing. Again, I'm reiterating a couple of points. This is foundational. It's very, very easy to jump into analytics and say, I can analyze a lot of data and come and give you a lot of information. But how critical or how relevant that information is the point that I'm trying to make. The second thing, there is no dearth of data. Enough and more data is available today. Now, what are you going to be doing with that data is important. And that's where I want to bring out the importance of telemetry. Now, what's the difference between telemetry and routine data? Telemetry is your ability to sense change in that data. Anything which is undergoing a change, I'm going to pick it up as telemetry and understand. Now, the telemetry can come from any source. The more sources you have, better your probability of making your analytics more refined. It could come in from a router, it could come in from a switch, a firewall, it could be coming in from your cloud infrastructure, your endpoints. There is no limitation on where you want to bring your telemetry from. But the point to note here is, are you sensing changes? And then comes the importance of doing behavior analysis from a user perspective. And again, I'm going to reiterate a combination of 2 points that I made to you. Point number 1, what are the competency questions that you've used on the data? Point number 2, are you sensing change? An example. You may go back and say, I want logs over the last 1 month of what has Anubhav done in the network. What all has he been up to? Well, there is no dearth of information. You can pull out all these logs, access these logs, and come back and say, well, this is the list of data that I have. Now, can I make some meaningful sense on tracking what kind of behavior am I doing, exhibiting? Number 1, after logging in, what did I do? What typical protocols am I being using? Is there a change? I typically just come in and do basic browsing, and now they're starting to see that I'm using a lot of FTP sessions. Is the session that I'm initiating coming in front of a machine via an RDP session? Have I done it before? How much data am I exchanging? Typically, is most of the communication I do encrypted or not? Am I seeing a change in that pattern? And so on and so forth. So the point I'm trying to make here is, I'm trying to establish baseline behavior basis which I can go back and determine changes. I'm trying to establish baseline behavior basis which I can go back and determine what are the right questions to ask. And that is setting the base for the right level of security analytics. You are not really looking for the right answers or the perfect answer. When it comes to analytics, your efficacy is on asking the right questions. And that's what I meant by starting off the conversation on competency. Now, this brings up to an important aspect of analytics in terms of understanding where does this data, where does this telemetry come from. Clearly, machine learning comes into picture. But was this or is it the only way we've done analytics in the past? The answer is no. Simple pattern matching, creation of lists. For example, you have intelligence coming back and telling you that these are indications of compromise, and if you see these indications of compromises in your network, please block it. And the stronger is your information, the more effective is your information, the more accurate is your analytics. This is simple. But the challenge with this is your list has to be high fidelity. Your list has to be accurate. And in changing and in a dynamic world, if that is not moving with time, it may become not extremely helpful to you. Then comes the statistical models, which have existed for many, many years. Average, mod, mean, median, all this can be used as well to pick and make sense out of the data that you have or the telemetry that you're consuming. But the key here is, can I ensure that I can move from human scale to machine scale? There's enough and more CPU, there is enough and more processing power on machines to make this effective for you. And the third thing that has been used in the past was first order logic and rules. Now let me take an example here. Let's take an example that typical behavior is that there are two workloads in your environment, workload A and workload B. And they have been typically exchanging or connecting with each other, exchanging information. I've also got a user by name Anubhav in the organization who typically only connects to user A. Now, as per the logic, basis my role, I should only be establishing connection with user A. And on very, very few circumstances, I have been seen to connect into workload B on an occasional basis. Now, if I come back and see that there is an indication of compromise on my machine, I can apply first order logic to infer that there could be malicious communication that I'm targeting towards workload A and B. So this is a very, very simple and a crude example of applying first order logic. And these are mechanisms or methodologies that were used before machine learning came into picture. But the key point here is machine learning helps you leverage machine scale over a user or a human scale. And why it is further more important is in security, you want to move away from lists. If you remember, I spoke about having a list of indications of compromise. The stronger the list, the better it is for you. But in case of security, that would be restricting yourself to a source of threat intel coming in from one particular source. And that's where you apply static learning. I want to move to a model where I can evolve, where the behaviors have been modified to local context. Let me take an example. There is a particular indication of compromise which talks about a typical behavior in the network where a user is trying to establish connection using non-standard protocols in the network. It's probably doing some port scanning activity followed by a couple of other activities. I'm trying to make first order logic by it, and I'm using static methodologies. Now this is global threat intel. I'm going to try and apply it. The problem is, if I am an attacker, I know where you're going to apply your controls. I know what kind of static lists that you already have in place. And that is where I will limit myself if I'm just using static methodologies to detect behaviors in the network. I need to understand if the attacker has modified the modus operandi. The goal may be the same, but the modus operandi could be modified to local context, and still the outcome would be that they would compromise. So if I need to go back and evolve myself beyond a static list, I need to ensure that the variability that comes in from a local context has to be applied. And that is where you will need a combination of machine learning with behavior analytics so that you can scale to it. So clearly, that's one of the reasons why you want to ensure that you can leverage the use of machine learning when you apply security analytics, which essentially means, as I called out, the data sets are huge. The advanced threats are going to make variations. And again, the ground rule here is machine learning is not magic. At the end of the day, you will have to ensure that your competency questions on what has been learned and brought in front of you are correct and are applied, reapplied, and reapplied to make them more accurate. This is not a one-time activity. Let me take a different example to explain all that I've called out so far. When I apply signatures, again, this is similar to calling out lists. And if I see a particular pattern X, I will go and sound an alarm. Again, if there are a set of particular actions that I see in consequent actions, I will again go and sound an alarm. Now, any attacker who's coming into your organization who knows you well enough knows that you've got these patterns already in place. You're going to be looking for it. So why will it go ahead and trigger the alarm? It will make a behavioral change, and you have to pinpoint that behavioral change to capture that particular attacker's behavior. To explain this in a little bit more detail, let me take an example of a chef's knife. Now, we all know what a chef knife is used for. It's used in the kitchen. It's got a sharp blade, a good handle to hold so that the grip is firm. Now, clearly, if the chef is using this knife from a behavior's perspective on Monday night to prepare a nice, sumptuous meal, I'm okay with it because the chef's knife is expected to do that. But on Tuesday during the day, it was used as a murder weapon. And in the night, a passenger was removed from a flight because they had an object with them, which apparently is this chef knife. Now, that's where I'm trying to do three things. Number one, establish what is the object. In this case, it's the chef knife. I have to be extremely sure that I am accurate in establishing it's a chef knife. And that's what is called as fingerprinting. We will evolve this concept as we move further. Number two, since I am accurate in knowing this is a chef's knife, I know what is the normal behavior of the chef knife. Every single day of the week, it is used to prepare meals. Now, I know this is a chef knife. I fingerprinted it. My ground rule questions were absolutely correct. I have classified it. Good job. I classified the behavior. Good job. Now, when I'm able to see a deviation in behavior of the chef knife, I can go back and establish that this is bad behavior and my accuracy level is going to be great. But again, reiterating myself yet again, the ground rule was that I established this as a chef knife accurately, and I classified the behavior of the chef knife accurately, which gets me to the important point. All our focus is on known bad behavior. All our focus in intel we are getting, we are looking for bad behaviors. The point I'm trying to drive here is what is not as a known bad behavior, according to you, is inferred as good. And in that good, there could be weird behavior, and in that weird behavior, hiding in that haystack could be those abnormal activities that you have to fish out. And that is where the importance comes in terms of doing very, very accurate role-based behavior detection, where from a lot of data, you label it and figure out, this is Alice, this is a PDF file, this is a laptop, this is a printer. And basis that, you classify behavior models. Example, I have classified this particular device in the network as a printer. The printer is expected to do a lot of communication on the network because I'm scheduling print jobs. But the moment I start seeing the printer establishing connections on AWS, either I have classified the printer incorrectly, or there is a bad activity going on in the network because the printer was never expected to talk to the AWS setup. And that's where every endpoint on the network has a role to play in security analytics. In quick summary, before I get into a little bit more detail and I'll pass it on to my colleague Aditya, let me summarize what I spoke of from the fundamentals of security analytics. The key is fingerprint correctly. know the object well. If you've known the object well, you can classify it and you can categorize what is the right behavior using behavior modeling. Example, the chef knife. It is used to prepare meal. The behaviors I've seen on chef knife is only that. And anything outside of that is not correct. The printer, good to see activities on the network, but definitely not seem to be talking to the AWS instances. And basis that, now when I am getting telemetry data from the network, I can marry the fingerprinting based classification and the categorization to bad behaviors that I don't want to see in the network. With that, I'm going to transition this to my colleague Aditya. Aditya, why don't you come in and take us into a little bit more details of what are we really talking from an artificial intelligence and machine learning perspective? Aditya, it's over to you.
Thank you, Anubhav. So first thing that I want to say is great examples that you gave. When you talk about artificial intelligence and machine learning, a lot of times those two words are interleaved, used interchangeably. I want to set a baseline of what do they exactly mean. Now, first of all, machine learning is the ability for computers to learn certain things without explicitly having been told those things. That's basically what machine learning is. And if you actually go ahead and see what artificial intelligence is the domain where computers and systems learn to behave autonomously. A subset of artificial intelligence is machine learning, a method of achieving artificial intelligence. And within machine learning, there are multiple types of learning methods within the machine learning domain. And we've got only three types being listed here. And because largely these are the three types that we see relevant to a cybersecurity world. Now, firstly, supervised learning, and Anubhav alluded to this earlier as well with the Google Photos example. Basically, in this type, you've got a data set and you've got a very good or accurate competency question to ask, and you know or have examples of that particular question being answered correctly, which you can then feed back to the engine saying, this is the question, this is what the expected answer is. If you find more of similar situations, you know what to do, right? An example of that would be, if you go ahead next, a friend of mine climbing a rock ice wall in the Himalayas. In this case, you can see there is an expert guide standing at the top instructing the particular person how they need to approach this. This is an example of an external input being given to that person to learn the method that's needed to climb that wall. So that's an example of supervised learning. If you go to unsupervised learning, there's a little bit less structure about the data. You've got a data set, you may not have the right questions, or you may not fully have the questions, and you don't even have the right answers all of the time. So you have some of the questions and you got some of the answers. It's basically a tool for understanding how different parts of your data set relate to each other and how you can make sense of it without external input, right? So an example of this is, you can see there is a track with a downslope and it looks like it's rained, so it's slushy. Now somebody who's trying to climb down this particular track is going to have to make a decision on, do I step on the stones and go further down? Do I skirt towards the left and go towards the muddy area, which is a little bit more safer? Or should I go to the extreme left and climb over the entire place and avoid this entire slushy area? You don't have an external input, you don't have anybody to guide you, and this is an example of unsupervised learning. You're put into a situation wherein you, based on the inputs that you have, you got to take a decision and move forward. Reinforcement learning is the third type, and this is the one wherein you've got a repeated trial and error method of learning. You take step one, you figure out that's right or not. Take step two, keep going till you get to a point wherein you get the right solution, right? An example of this is going to be if any of you have gone to the Himalayas in in the peak winter, the rivers freeze over, and you've got people, the village people, walking across multiple village to a village over the frozen river. How? And there is no science of walking across the frozen river. You take step one, you fall. You take the step two, you get a better balance. Keep doing it again and again till you get to a point wherein you're confident about the steps that you're taking. Right. So that's reinforcement learning. What this brings you to is all of these different types of learning that you use are basically meant to fine tune the algorithm that you've got for your analytical outcome. A lot of times this is largely the focus of improving the outcomes that you're looking at by improving the analytical algorithm. But the important piece also to remember is the training data that you feed the engine. That is a very important piece. It plays a very important role because the broader the training data set that you feed to the engine, the more examples of the questions that it can run through, the more examples of outcomes that it can look at, which is going to end of the day help with defining the classifiers. The more data it has, the more examples that it can run through, the better the classifier can be made into, so that when you've got the classifier working for your new data, you have a better or a more accurate prediction. So what does this classifier look for? So what does your engine look for? End of the day, the security analytics engine is going to look for observables. Observables are, in simple words, anything that you can measure in the observational domain. If you look at continuing the mountaineering example, if you look at the first one here on the left hand side, this is an analog altimeter. This was one of the ones that was used by the first people who climbed Mount Everest. So George Mallory in 1924, he used an altimeter exactly like this. What does this particular device give as an output? The primary thing that you can observe is just an altitude. That's the only thing this was used for. Now fast forward today, 100 years later almost, you've got tons of people going up to all of the highest mountains in the world. They don't use dedicated devices for an altimeter anymore. They've got a sports watch that can look at not just altimeter, not just an altitude, but it can give you how much have you ascended by, what's your heart rate, and a whole bunch of other information that's useful for them. So a lot of things that it can observe.
So I think what we've just done is, and that was a good context setting, but what we've just done is we've just rolled out a very quick poll, because this is a segue into an important thing that we want to know from the audience, which is, given the increased percentage of encrypted traffic, the data between the endpoints and the critical application is mostly dark. And in such a case, do the audience still see the relevance of running network traffic analysis? So we'll give about 20 seconds, and as soon as we've got the results, we will move into the next slide. All right, so the answer is 64% of the people say yes. And yes means yes, they still see that there is relevance of running network traffic analysis. The others are saying, and that's a huge number, you know. So Aditya, you've got a very, very important task up ahead of you. I'm progressing the slides. We need to give this response back to the remaining 56% of the audience to let them know, why do we still need traffic analysis, given the fact that most of the impact is going to be on the endpoints and the critical applications. Everything in between is dark. Over to you, Aditya.
Great data point with that particular question. So quite interesting, and I can see the trend for the poll going slightly towards the yes, as in more and more people finding this particular use case being relevant. So there's less and less people that I need to convince. That's interesting. So,
Right.
I mean, coming back to the question at hand, when you were historically looking at observing things on your network or trying to get data points from your network, you largely had to look at connections from your clients to the servers. The clients were largely defined, the servers were largely defined to some extent. You could observe traffic that's going from one point to another point. You had a lot of choke points that you could put in tools to look at observations. In today's world, that's not really an option anymore, because not only your definition of client and server is sort of merging or not defined exclusively anymore, but you also have situations wherein you've got multiple types of network, you've got multiple devices in between, you've got firewalls in between that are doing NAT, for example. So you've got a hop in between that has your initial source and destination being changed. You've got proxies that are inspecting your connections. And if with the advent of software defined networking, you've got differed network architectures. You got an underlay and an overlay. Where do you actually focus information from? Do you need to get information from both? Now you need to look at not just layer 3, you need to look at layer 4, you need to look at layer 7, you need to add in information from a lot of different places across your network, because there are a lot of different things on the network doing various functions. So in that context, is looking at data on the endpoint alone sufficient? And when I say endpoint here, I don't mean a client workstation alone. I've generalized the client and the server to be a consumer and a provider, because a lot of times that can the role of that particular endpoint can change. So for your client endpoint, do you want to put an agent and have protection delivered through that agent? Likewise, for your provider being the server, you put a workload protection agent and have your security controls driven through that. That is one option. But one of some of the other things to remember is your network never lies. Anything that happens on the network is happening on the network, which is anything that you observe on that network is things that you can get as a fact, because that's happening on the network. The other thing, why would you wait for your threat to reach your crown jewels? For example, if somebody is actually doing reconnaissance activity against your workload, why would you want to wait until that recon activity, until somebody is doing scanning and trying to attempt to brute force into your workload, to actually know that a recon activity is happening on the network? Looking at the network will give you that information much ahead of time. And lastly, can you, if you just go back to the previous slide, Anubhav, if you cannot you really put agents everywhere on the network. It's not practical, it's not scalable. You've got a lot of devices with your extended network. If you look at IoT, if you look at industrial network with operational technology endpoints, a lot of unmanaged devices. You cannot really put an agent into all of these devices to protect those devices. And what about threat actors that stand up rogue devices on the network? Things that are not official, that are not part of the legitimate network infrastructure. You don't have any visibility into that. And malicious actors more and more are going to be using encrypted traffic so that they hide in that haystack. So how do you, this is the reason why just looking at endpoints is not sufficient. You have to look at the network, and when you're looking at the network, you've got to look at various data points across the network, right? And if you go to the next, that's where you can see, all of the various data points that we can that we should look at collecting information from. Put all of this information that you're collecting it through your modeling engine to model all of the traffic. So you're not just looking for bad traffic, you want to look at modeling all of the traffic, identify what normal behavior looks like, track each of these devices, identify what the device functions as, identify what kind of connections it makes, so that you get a sense, so that you, as in the engine, gets a sense of what is normal for that particular device. Then you can look at outliers, perform analysis to find what is normal expected behavior for this, what can then be classified as deviations. So that brings us to the next section of the session here, which is how do you actually apply all or some of the concepts that we just spoke about to a real world problem. And we spoke about how encrypted traffic analytics is a significant challenge in today's world. Why? Because primarily a large percentage of the network traffic is encrypted, in excess of 90%, and that's not going down, it's only going up. The downside of this is even the bad guys are using encryptions. Even bad guys are using TLS. Nobody is looking at HTTP or FTP as a method to do malicious activity on the network anymore. It's all TLS. Everything is dark. But the silver lining in all of this is all encrypted sessions begin unencrypted, which means now you've got about the encrypted sessions that you can capture by looking at the sessions before they get encrypted. We spoke about how direct inspection is no longer possible because of a variety of different advent of different technologies, right from software-defined networking to encryption technologies. A lot of different requirements have driven the need for inferring observations in your network. Look at traffic, infer what you cannot directly observe. So with encrypted traffic, I spoke about how you can look at all of the encrypted traffic begins unencrypted. So when you look at telemetry from all of the traffic at the starting, you can capture unencrypted observables. Now, these are information that you can capture, store as a fact because they are unencrypted. You have visibility into all of these parameters. Anything that you capture from here can be stored as a fact. Then when the session gets encrypted, now you're looking at the dark data. So what can you capture from there? Look at observables, fingerprint those observables, attribute those fingerprints to certain processes, which can then help you to do analytics and achieve some of your outcomes. So let's go deeper into the fingerprinting aspect. So what does fingerprinting actually mean? And I'm going to use some of the outcome of research done by some of esteemed colleagues from the Cisco organization here. So if you go ahead to the next slide, we can see when you're talking about fingerprinting, what do you actually mean? The objective is to observe a pattern of traffic in transit and capture information that can accurately identify what process is responsible for exhibiting that pattern on the network. Now let me take an example here. So going back to the mountaineering example that I spoke about earlier with the altimeters that George Mallory had used in 1924. If you think of that same object again, you can look at the observables. When you look at that object, what are the observables? You can, looking at the dial, you can make out the company that manufactured it. On the dial, you can see it has markings up to 30,000 feet, and it has a single pressure hand to point towards a particular altitude. These are the things that some of the things that you can observe. By looking at those observables, what is the class of object? By looking at that, you can make out that is an altimeter. Now, the important thing is, just by looking at that piece of information, you cannot accurately, for a fact, tell me that is, in fact, George Mallory's altimeter that was used in his fatal climb to Mount Everest in 1924. Now, that's the important piece we're going to get at. Identifying the class of object is the primary source, primary activity. How can you go close to identifying what that instance of that particular process is and tying that to relevance of the environment? Now, in the cybersecurity world, when you're talking about TLS fingerprinting specifically, what you're looking at is observing patterns that are used for negotiation observing parameters that are used for negotiating the TLS session, classify them as observables, and attribute those observables to a certain process. For example, you observed a particular observable that can be attributed to a Google Chrome process. And likewise, various other observables can be attributed to various different processes that can then be used for different kinds of analysis. Now, in some cases, how accurate is this attribution? That becomes important. The key parameter in that case is how good of a database do you have? The larger the database you have, the more accurate your attribution can be. But in a lot of times, is the specificity that important? In some cases, need not be. In some cases, you might have an attribution saying this particular observable is Google Chrome. That might be sufficient in some cases. Whereas in some other cases, it might not be sufficient to just know the process. You might need additional data points to distinguish different types of that processes in different instances. So you might need to get to a specific version, you might need to get to a specific OS, specific patch, depending on the level of analytics that you're going to do. Now that is the important thing. Like I said earlier, attribution of a particular observable to a process is step one. So now you know what you're dealing with. Step two is where the importance or the relevance to the actual outcome or the business that you're looking at. Is that observable? Is that attribution that you have done malicious or not? Or is that is the decision of it being malicious or benign specific to that particular environment? That is where the relevance of the environment that you're doing this process comes in. That's where the context comes in. This particular context point brings me to the next section, which is the only way that you're going to get a lot of this contextual information is by identifying the behavior of your various processes. So an example of this is in line with what Anubhav mentioned earlier. You identify an observable on the network, you attribute it to a process that is linked to a printer, which means that observable is linked to a process which is only seen on printers. If that is the case, now you know what is expected behavior from that particular endpoint. Any deviation from that behavior is straight away can be flagged as activity, suspicious activity that needs to be analyzed deeper further. An example is connections to AWS or any other scanning activity on the network. So a lot of different activities that are not part of what is the known behavior for that particular process. And a lot of times it is that particular attribution or the identification of good, malicious, benign is not just a single level, right? It's not just, I know this is a printer, I know these are the three things it's supposed to do, anything else is bad. It's not that simple. You end up having to do multiple levels of inference. The reason is you might have a particular observation tied to a particular process, which might be seen on a particular version of the app. In some cases, in some environments, that app is a legitimate app, part of the business required to run, and not a threat. In some cases, that is not legitimate and might be part of a process that is used for a global threat campaign, or might be a vulnerable process according in that particular customer's environment. In some cases, it need not be a necessarily bad activity, a process related to a bad activity, but can be something that is violating a certain policy on the network. So multiple levels to identify bad activity, suspicious activity, and benign. Differentiate between that through multiple layers of inference.
Yeah, I just want to interrupt really quickly, Aditya. I think there's somebody who has a question here. So may I please request all the audience to post their questions on the Q&A panel so that we can take all those questions towards the end of the session. Thank you very much.
Sure, thank you. So coming back to our encrypted traffic example. Now, if you look at the way you have observations for legitimate traffic versus traffic that can be associated to bad behavior, right? There are inherently a lot of differences in the way the pattern of this traffic, the patterns that these traffic exhibits. So a legitimate web traffic search, in this case, let's say Google search or anybody doing legitimate traffic, the pattern that can be seen is going to be starkly different from a compromised endpoint initiating a command and control traffic to the CNC server, or the same compromised endpoint now having retrieved instructions, identified the key pieces of information that it wants to exfiltrate, and is exfiltrating that data. The important pieces here is the pattern of the traffic, the arrival times of various packets, the relationship between the arrival times of these various packets, the length of these packets, the timing of these packets. A lot of these different parameters can be observed. Since they are now encrypted, we are observing all of these metadata about that particular connection and using that for our analytics. So if we look at the encrypted traffic analytics, the kind of telemetry that we need in the first place, remember all encrypted traffic starts unencrypted. So when you look at unencrypted portion of the that particular traffic, you're looking at the initial data packet. The initial data packet, like if you remember what I said, it's got observables in clear text. Anything that you capture from that is things that you can store for a fact, because they are unencrypted, you know them accurately. Once they are encrypted, you look at the sequence of packet lengths and times, the timing of the packets, the relationship between packets, arrival times of these packets. All of these pieces of information are your primary telemetry for running analytics. And you run these analytics through multiple layers of inferences that you can then look at the outcome being detecting a presence of malicious activity in that particular traffic or not. And if you look at the 4 steps that I spoke about earlier, and you can tie those 4 steps into the various stages here, right? So the initial data packet is going to have the unencrypted observables. Anubhav, if you could move ahead. The sequence of packet lengths and times is the one that's going to give you the ability to extract observables attributed to a process. The analysis is then going to give you additional capabilities of identifying what these processes are, attributing it to a specific process, depending on how expansive your database of fingerprinting is, which can then be used for generating helpful analytical outcomes. The key thing, if you remember what I said last, is helpful analytical outcomes, right? And this is an important point to look at in terms of the outcome that you're getting. Is it helpful or not is the first question. The second question is, how accurate is it? And this was you guys have answered one of the poll questions at the starting of the session, alluding to exactly this. Now, going back to my mountaineering example, where I spoke about George Mallory's fatal climb to Everest in 1924. Obviously, I've done a lot of research around that. And when I look at reading George Mallory's story, if I go back into Amazon or any of the bookstores, online bookstores, what it's going to look at and tell me other related topics that might be interesting to me. In this case, all of these other stories here are definitely interesting and things that I have read, which is the outcome that the engine is telling me helpful or not? Yes, it is helpful in this case. But even if it was not helpful, what's the big deal? The stakes are quite low in this case, or not so significant. If you go ahead to in the cybersecurity world, the stakes are not as simple. They are a lot more complex. So next, now, literally stealing a slide from what Anubhav mentioned earlier. In the cybersecurity world, you need to explain, you as in the engine needs to explain how it did it come to a particular conclusion, and explain it in a way that the consumer can consume that particular piece of information. As in, if I found suspicious activity, how I as in the engine, how did I go from identifying what is normal behavior for my endpoint? How did I identify this being suspicious? What parameters did I use to classify that suspicious behavior being malicious behavior, which then needs to be remediated or taken an action on? How can I justify this and provide this, the, let's say, the life cycle of that particular detection, and solve the explainability problem? Have the machine explain what steps it took to come arrive at that conclusion. That's the important piece. Now, with that, I will hand it back to Anubhav for the next section to look at this specific topic exactly.
All right, thank you so much. And I think I'm going to start converging all that Aditya spoke. I think he's given us a lot of important information. I'm going to piece this all together and make a final commentary on this. Clearly, what we need to be effective in security analytics starts with having a multi-layered analytical pipeline. What do I mean by that? If you recall, I started with going ahead and tapping into multiple data sources. And I said, more than the data, I need to pick up telemetry. And if you recall, I said telemetry is sensing change. What was the change in data? The larger the base, better is my fidelity on picking up behavior changes. Now, from that data, if I've done my job correctly of fingerprinting, and if you recall, Aditya spoke about TLS fingerprinting techniques. The better I have accuracy in doing the fingerprinting, the better I have in understanding what is the behavior this particular object has to exhibit. I know that a chef knife has a particular behavior to exhibit. And similarly, basis these techniques, once I have been able to do the behavior-based modeling, I am now in a better position to apply deviations. I'm now in a better position to understand if there is a compliance deviation or a behavior deviation, or if there's a bad actor in the playing up, trying to deceive or evade all the tools that you have put in place. Now, let me take an example from a security perspective to explain this to you. Maybe on December 9th, you have gone ahead and concluded that there is a particular user by name Sality who has malware on their machine. I am more keen to know what was the activity that led up for me to believe that this is a malware. More often than not, our focus is believing and trusting the engine that is coming back and telling us that this is bad behavior. We want to see and question that the ground truth that was put in place to ask the right level of questions was correct. The behavior modeling was correct to come back and make a deterministic decision that yes, this is a malware. More often than not, we tend to miss this piece when we are running analysis or security analytics, and that's where we start creating noise and false positives. Now, this gets me to the conclusion phase of this talk, and this is where we will segue into showtime. We will show you some of those things that we've been talking about. Clearly, what we tried to bring up here was importance of good broad-based telemetry that gets used in the synthesis that I need to do for effective analytics. And that analytics is driven by great competency questions, accurate competency questions, achieving the outcomes around what problem is being solved to different stakeholders in the organization. Clearly, I want to ensure that those 5 questions, the answers to the 5 questions that the security analytics, the incident responder is looking for, are being answered with this security analytics. And if it is not, I am creating noise for that person. Most important part, which we did capture in the presentation, but often gets ignored: feedback. Now, as we all understand here, this exercise cannot be 100% accurate, which brings up the important aspect of closed loop feedback. If an alert gets generated from an analytics perspective, there has to be a mechanism with the user to go back and tell you, was this alert helpful or not? And if it was not, it should go back and recheck the competency question that was used to bring out the analytics. And hence, any security analytics solution that is being built has to build in effective feedback mechanisms that go back and re-engineer the competency questions. And that could be done for two reasons. One, maybe the algorithm was not effective enough. Two, the baseline is changing. I am now seeing the chef's knife not being used so much to prepare meals. The task has changed. It is now being used as a utility device in the kitchen, maybe to cut ropes or do something else. The baseline is changing. And that's where the feedback loop comes into picture. And that's the relevance that matters. It is not about how many alerts I generate. It's about what outcome did the alert drive for me. So clearly, in summary, from a security analytics perspective, there's enough and more data. I want to ensure that I apply advanced analytics on machine scale, but it should be used on human scale. Number two, when you're applying analytics or when you're using analytics, please ensure that getting the question right is your battle, not getting the best answer. And the goal, as I said, is not just the precise answer, but asking that right question for you. And remember, your baseline will change over a period of time. You have to apply relearning. You have to go back and recheck your competency questions because this is a moving target. So with that as a summary, I'm going to get you to the best part of our presentation, which is showtime. And may I request if the presentation rights can now be passed on to Aditya so that he can showcase the dashboard he's going to use for his presentation.
Hey Anubhav, can you confirm that you can look at my screen now and hear me clearly?
Okay, I can see the screen now, Aditya. Just to
I
check.
hope you can hear me as well.
Yes, I can hear you clearly. All right. So let's start with the first question, Aditya. We've spoken a lot. Let's bring life back to the real world. I think all of us recognize that in today's time and age, there is a lot of adoption of the cloud, the public cloud. Organizations have understood that the agility required today in cloud adoption is the way to go. Now, in this scenario, my first question to you is, how can you bring in analytics to understand what's happening in the public cloud world, what's happening in my own environment? Is there a breach which is brewing up? Can I have predictive analysis to tell me something is cooking, which I need to focus on before the attack actually launches and executes itself on the endpoint? So can you take this question and show us how we would do this?
Great question, actually, and very relevant one, like you said, in today's world with the adoption for cloud. And one of the first things that you said is, can you tell me what's happening? That is, in a lot of times, that is the first question that most folks who are using various cloud solutions ask. What's actually happening in my cloud? So, I mean, I've got a tool here that's going to give us some of the analytical outcomes. Before I actually go into the outcome specifically, what I wanted to show is, when you look at a cloud infrastructure and you can see in this particular case, I'm showing an AWS visualizations page. So basically, I've got an instance in AWS. I've got a VPC there. I've got a bunch of subnets under that VPC, and I've got a bunch of resources under that subnet. In this case, a whole bunch of EC2 instances. It can be anything, right? It can be infrastructure as a service. It can be platform as a service, software as a service, a whole bunch of stuff. This is a lot of times not something that most of the customers have a good handle on in the first place, which is why breaches in the cloud are not exactly easy to identify or get to the root cause of. Now, with that said, we'll go specifically into some of the outcomes and look at a case of what are the various breadcrumbs that situation of a breach in the cloud would leave back, and what are some of the outcomes that the solution can look at by looking at those different breadcrumbs. So now what I'm doing is looking at alerts that the system has given from an in an AWS situation specifically. So you got a bunch of different alerts here, right? We'll go look at the first one here. Somebody is the AWS infrastructure that I showed earlier. Somebody is trying to brute force login into that. Now that's an infrastructure that has access to the internet, which means there is legitimate access from the external world expected on that particular system. But as you can see here, we got an alert, we got a description, and we got the justification behind that particular alert. What are the supporting observations that it made? You can see this particular user, Patron, has logged in or attempted to log in to this particular AWS console from the United States. In this case, it looks like from a domain that is not instantly recognizable to me. So not exactly expected behavior. So I got an alert for somebody trying to break into that particular system. Now that particular the same user, let's say they are now able to break into that AWS system or log into the system somehow. Now we have another alert saying I've got a geographically unusual API usage. So I've got an API key in AWS that was not secured fully, fell into the wrong hands, in this case the user that's trying to brute force into it. And now under the observations, you can see this same user has tried to log in from a different country. So now in this case, he's trying to log in from Japan. And you can see he's able to successfully log in because now he has the API keys, which is in the cloud world, keys to your castle, right? So what does that particular user do once he is in your infrastructure? So you got a malicious actor inside your infrastructure. He's going to make changes to the rules so that things are not as secure as previously. Now we got another alert saying a permissive AWS security group has been created. What does this mean? Basically, an equivalent of your firewall access rule in the cloud has been modified to not be restrictive anymore. Something like an IP any rule in the cloud. So basically, opening out that particular instance or VPC into the external world. So that same user has now expanded the permissions to that particular resource. What does he? Well, now that the resource permissions are lax, what does he do next? Since it's opened out to the entire world and does not have any restrictions anymore, we get multiple users from across the entire world. Different regions are going to bombard it. It's open, no restrictions. People are going to bombard into it. So you get geographically unused remote access alert. If you look at the observations here, this particular instance has been accessed now from a different endpoint from the United States, from different entity in this case. Since the restrictions were limited, now the access is not primarily a web console anymore. The RDP port is open, so somebody has been able to remote desktop into it.
So Aditya, I want to pause you here for a minute for the benefit of the audience. Can you give me an example of, or rather, can I confirm that the categorization that we did during our presentation, when we said I've tried to categorize behavior basis fingerprinting. So can I say that the profile is that of an RDP server? That's an example of fingerprinting the object. And determining what kind of behavior to expect from this RDP server is the behavior analytics associated with it. And the numerous instances of observables that you're generating are basically coming from the large telemetry that you're tapping into. Is that a fair articulation of what we spoke during our presentation?
That is, in fact, is a very accurate articulation of the aspects that we spoke about earlier. So putting it in another way, what the tool does when we spoke about capturing telemetry from different parts of the network, feeding it to the engine that would then make judgments on what is expected behavior for that particular endpoint. So in this case, we've got this particular instance, our EC2 instance in AWS, looking at the traffic that this particular instance typically generates, establishing that baseline. The system has been able to classify that into a remote desktop role. That is something that is the outcome of the engine. So now that we know that this is a remote desktop server, it looks at what are the typical connections that this remote desktop server makes, who usually accesses it. The alert in this case is specifically saying, I've got an endpoint on the internet that I've not seen before, accessing this particular instance through a profile that is typically expected of. So the key aspect here is an endpoint that has not typically accessed this particular service on that particular profile, on that particular endpoint, is what is flagging it.
Now I'm going to ask you one more tough question, Aditya.
Go ahead.
What you did not have this analysis with you? Well, we asked this question during the poll that, well, most of the data is encrypted. Why do you need behavior analytics? You could typically run analytics on the endpoint and on the workload of the application, because that's where the actual activity or the malware is going to execute. So you could probably use this as an example to showcase whether what was the importance of this analytics, or segue into telling me how would you showcase my malicious activity in the network, and how could you predict a possible breach coming in future, and how could you determine the level of confidence, because all this is more of something leading into an attack. So you better have some level of accuracy or some level of confidence when you're doing this.
Absolutely, and this is exactly what I was going to show next, right? All of the things that you've seen now are indicators of compromise, right? And only now we are seeing something that is based on a behavioral analysis outcome, right? So once somebody who's a threat actor is accessing this particular infrastructure, now we spoke about the endpoint being seen for the first time. Once they've actually done, or they looked at the critical pieces of information on that particular infrastructure that they found interesting and they want to exfiltrate. Now, this is where a lot of the meat of the behavioral analysis discussion comes in. Looking at what are the typical connections this particular endpoint makes, as in, when I say endpoint in this case, any endpoint in that infrastructure, what connections do they make, how much data do they transfer, what kind of profiles do they use. Based on that, it establishes the baseline, and now what it tells me is that particular threat actor has exfiltrated a significant amount of data from that particular endpoint in the cloud to a destination external to the network that was not seen before. What are the justification behind that? What is the kind of connection it makes? How much data transfer was done? What kind of connection was it? What profile was used? Now, this is where you get specific in this case. Now, what it's telling me is this particular endpoint was the exfiltration in this case was specifically by this particular user who is exfiltrating data from this particular endpoint through a Dropbox connection. So it's going out to this particular server, which is Dropbox in the United States, using a Dropbox protocol client profile. And if you look at the metrics that was known about this particular profile on that particular instance previously, it was not seen before. We had not seen any Dropbox connections before, whereas now we are seeing a huge amount of traffic using this particular profile. So this is an example of the behavioral analysis, the outcome that it did, and the justification behind that analysis, and the data points that it used to actually come to the conclusion that there is somebody attempting to exfiltrate data out of this network.
Great. And so this is so. And how do you know what level of confidence we have on this? As in, can we say with fair level of confidence that this data is correct and there was malicious activity here?
Absolutely, you can, primarily because if you remember, we spoke about how observing traffic on the network is important, because anything that you observe on the network is examples of activity that's actually going on the network. So your network never lies. You are capturing information from the actual network, and the system is coming with outcomes based on that.
Great. So I think what I'll do is, since we are just 13 minutes left into the presentation, why don't we just quickly summarize and take on some questions, because quite a few questions apparently came up as well. I think we'll move quickly to a question answer mode. I'll just while the questions keep coming up, I'll just quickly walk through the key takeaways. Again, there are certain good principles for us to apply on security analytics. It's not a perfect world. We need to be pragmatic. Well, you have to go ahead and question the ground truth. One time, first time, every time. Do not rely on one single technique. Ensure that you can bring a larger analytical pipeline. Let's be real. It's not about how many alerts got generated. Let's measure whose problem got solved and how helpful was the alert. And clearly, all of us are a part of this community. Let's share learnings. Let's go ahead and be transparent on what we've seen and observed. The idea is to keep the bad actors away and make ourselves stronger against them. So with that, I think I will just read out the first question that I have. And the first one is, would you think that people working on security analytics should be mathematicians or security professionals, or a blend? I love the question. I'm going to take a stab at it first and then pass it on to Aditya. Well, I think it's a combination of both. I'll tell you why. Security professionals understand the domain problem. We understand, for example, I gave you a good example of analytics being used in your daily life, and it serving as a direction, or it's serving as something that can give you broad guidance, versus applying analytics accurately. And that's only somebody who understands the domain will be able to feel for. The other is somebody recognizing or appreciating what's the ground truth, what's the baseline to be used, and being able to provide it to somebody who's a mathematician or a data scientist to be able to give you methodology. So clearly it's a blend. The security professional brings you the perspective and the domain. The mathematician or the data scientist gives you efficient ways to make it effective. Aditya, do you have any commentary on it?
No, I think you summarized it pretty well. The only thing that I would add to that is there are going to be different parts of the analytics tool that requires more of a data science or a mathematician in terms of building the machine learning engine, for example. Whereas bringing in the consumer point of view or the end user point of view in terms of the persona that are going to be using the outcome of this tool, that's where the security practitioner can bring their value in. So 100% agree with you, Anubhav. There's got to be a blend of people in this case.
Great. Moving on to question 2, and I think Aditya, you're the best to answer this one. It says, do we consider leveraging data that is readily available and can easily be collected for security analytics?
We probably need a little bit more context to that, but I'll take a stab as is. So when you say readily available versus
No, there's no verses. I'll repeat the question. I think it's clear. Do we consider leveraging data that is readily available and can be easily collected for security analytics?
So we spoke about how you can collect information or telemetry from different parts of the network. Now that is something that is not it's not something that needs to be manufactured or needs to be processed significantly. That's something a lot of devices have various methods of generating telemetry, can be from syslogs or process logs or flow telemetry across the network. A lot of these things, the method of generating this telemetry is largely with the respective data source. It is up to the engine to collect this information from those various sources on the network and parse the information, process it, and understand what those data sources are. So I would say things.
Let me take a different view to this, because I think it's not, the question is not so much about how do we process it. The question is, where do we get the data from, if I understood the question. And the answer is, well, it's easier to start with what you have rather than going and looking for additional data or telemetry to go and run analytics on. I think that bases the limited information we have on the question. I think that's the only thing I could reasonably tell you, that you can't create or manufacture data. You can't create or manufacture telemetry. So best is to start with what you have and see if you could make meaningful decisions with it. Remember what I said? It's not about how many alerts that you get. It's about what problem did it solve? Because if you were going back to the same data or that same telemetry source to get answers to those 5 questions that you ask yourself every single day, and if that's the data you're going to look at, so be it. Run your analytics on it. What do you think, Aditya?
Yep, agree.
Okay, moving on to question number 3. Now, what are the key differences between user and event behavior analytics, which is UEBA, and XDR, which is extended detection and response? And which one do we need?
Okay, so this is a very domain specific question. So interesting question, and something that part of this question is something that I get asked quite often. Now, when you look at how you have different market segments and different security tools looking at solving different problems in the analytical domain, you've got certain tools that look at basically information about what is a user doing on the network. And that's where the UEBA tool comes in. You've got certain devices that are looking at what is the endpoint doing. So that's where your endpoint detection and response tool comes in. Then you've got certain tools that are looking at what is actually going on your network, not specific to a particular endpoint itself, but what's actually going on in your network. That is defined as the network detection and response tools. Now, if you actually look at the industry analyst's definition of what XDR is, or extended detection and response, they largely classify it as something that is EDR plus NDR equal to XDR. So a tool or a set of tools that can look at what's going on your endpoint, provide detection capabilities, analytical capabilities, and response capabilities, and do the same or likewise with telemetry from your network. So that is XDR.
Now, the part of the question that's remained unanswered is, which one do we need?
Exactly. I was just getting to that. The long-winded answer to that, or in fact, the short answer to that is you're never going to have a situation where one is enough. You always have different threat vectors that your NDR solution is going to detect. You're going to have different vectors that your EDR solution is going to detect, and likewise different vectors that your UEBA solutions are going to reflect. there might be some amount of overlap between certain aspects of what a UEBA does versus what an EDR does from an entity or an endpoint point of view. There might be some overlap from between what UEBA and NDR does from a network observational point of view. Yes, there is going to be overlap, but you're going to need depending on the outcome or the use case or the problem that you're trying to solve, there might be a case of one tool having slightly more priority in that particular situation compared to another tool. But for to complete your or get a complete protection against all of the threat vectors, you would probably need a combination of those tools.
So if I want to summarize what you said, can I say that safely? Your XDR solution is going to leverage your UEBA solution to do effective threat detection response. So they both need to coexist and live together.
Yes, absolutely.
Okay, moving on to question 4, and I think I'll take this one. What are the top two specific problems companies should focus on solving? I love this question. I'll tell you why. Because most people would want to jump into adding more security capabilities. I need to know more. When I would say the top focus area, the top problems companies need to solve is, can I ensure that I can make the life of the security team or the security researcher or the security analyst simpler and easier? Can we reduce their fatigue? I think that's the number one problem we all need to work towards, because there are very few of us who can really do these particular tasks. And if we are overwhelmed with too much of information, too many alerts to look at, I think that's the number one problem for us to solve. How can you make your security operations far more effective and far more easy and simpler to use? That's the number one problem I would look at. The second problem I would look at is, everybody talks about visibility, and that's becoming the buzzword in the industry. Everybody starts it, and I've seen most people start a security conversation with enhancing visibility. I think that's basic, that's foundational. But more than that, can you go back and ensure and have KPIs to measure what was the effectiveness of the alerts that you received? I think that's one problem that we need to solve. And can we put in a closed loop feedback to ensure that there's continuous learning, there's continuous input to go and improve the efficacy of those alerts? Because alert fatigue is something that most organizations struggle with. Now, again, everybody has a different perspective to it, but this was mine. Aditya, do you want to add something?
No, I think I 100% agree with what you just said, and those exact same thoughts were in my mind as well. How do you simplify the operations, the role of the analyst, the role of the CISO? So simplifying security operations and having an effective security operation structure. So those are the primary two problems, I would say.
Okay. The last one is, and well, Aditya, I'll give this one to you because this is a tough one to answer. I know what your answer is going to be, but yeah, I don't think we may be able to recommend any tools here. But yes, the question is, which is the best tool available in the market incorporating security analytics and real-time alerting? There are quite a few, but I don't know if we're in a position to recommend anything. It depends on your use case. It depends on what particular vector you're focusing on. It's a very, very broad question. But anyway, Aditya, why don't you take it? You are the expert in this field.
Yeah, so without leaning specifically to a very specific tool, obviously, like you said, we got to understand what is the problem that we're trying to look at detecting or protecting against, and based on that, it's probably a good idea to look at a defined industry analyst's view of
Vito, you can. I think you can take back. We lost Aditya for a few minutes, but I think we lost Aditya for a few minutes. But I think what Aditya was saying, I'll just quickly conclude what Aditya was saying. He was just saying that it depends on the use case. It's a very broad-based question, very difficult for us to come back and tell you which tool to use. Obviously, if you ask me, I will be biased, but yeah, we can probably have an offline chat conversation on this.
Yeah.
Vito, back to you.
Yeah. Anubhav, I think there's a last minute question if you want to entertain this. Probably
Sure,
this is the
please.
last one.
Please, please.
Here, okay. The question is here we are heavily dependent on network behavior, and you told network never lies. But what if attacker use packets to camouflage, and as a result, packet detection is not able to detect that malware? There, you don't think the detection will fail? That's a question.
Nice one, Aditya. Are you back? I think this is where we need you to go back and talk about encrypted traffic. Do you want us to repeat the question, Aditya?
Are you there, Aditya?
No, we can't hear you.
Okay.
Okay, so, well, the question was if there is a deception technique being used by the attacker. Now, if you remember, Aditya spoke about a methodology where you can do encrypted traffic analysis. Now, what you said is something similar to what Aditya was also explaining. Encryption is a way where you encrypt your traffic in such a manner that any analytical tool will not, unless you decrypt it, will not be able to work on it. But looking at certain basic parameters of the traffic, such as inter-arrival times, the length of the packet, uh, where are you communicating to? Now, this is information that can be used even if the traffic is encrypted. And this exhibits behavior. So when you use the word camouflage, my understanding and interpretation was camouflaging it by encrypting the traffic. And encryption is basically a methodology that attackers would use to camouflage themselves or evade security sensors. So using encrypted traffic analysis, the methodology that Aditya spoke of, is a good way to detect these kind of behaviors. And all you're using is basic information in packet headers, inter-arrival times, packet length, whom are you talking to, what's the duration, what's the quantum of data being exhibited. And with a global inventory or global intelligence available in terms of bad behaviors versus good, with fair amount of accuracy, I'm not saying it's going to be 100% accurate, but with fair amount of accuracy, you can determine those outliers.
Well, thank you so much, Anubhav and Aditya, for your great presentation. To our audience, we greatly appreciate you listening in. Until next time, take care, and we hope to have you back again for next chapter webcast on mobile security.
Thank you so much, Pedro. Thanks, everyone.